Good afternoon, friends. Now, today we should be discussing the second part of the law of gearing. The first part I have been discussed in my first in the first video, and this is the second part of the law of gearing. Which now in my first lecture I have shown that the common that the line joining the point A and B, the line joining the point A and B divides the common normal of the two gears, that is Fe, into inverse ratio of the angular velocity. This is the first observation. We got observation number 1, and the observation number 2 is that that the common normal must pass through the pitch point. That the common normal at the point of contact of the two mating gears must pass through the pitch point P. We have shown that the common normal from the point of contact must pass through the pitch point P. So these are the two observations we obtained. So the second observation is depend on the first observation only. So we have rather two observations from our first lecture. Now in the second lecture, in my second lecture of law of gearing, we should deal about the velocity of sliding. Now we know that there should not be any movement of the gears along the common normal. The reason behind is that if there is a movement of the gears along the common normal, what will happen? Penetration will take place. So we have taken the cosine component of Vc cos alpha and Vd sin beta to be 0. So we have, if you see my first lecture, you see we have taken the cosine component is 0 because we have considered that there should not be any relative motion along the direction of the normal. Now we consider the the sine component of the velocity Vc along the tangent and Vd along the tangent. There have to be a relative velocity between this. Here it should not be 0 because for the motion of the gears, for the transfer of motion of power from one gear to another gear, the gear must slide. So for that reason, the sine component of Vc, that is along tangential direction, that is Vc sine alpha, and the sine component of Vd, that is Vd sine beta, that is Vc sine alpha minus Vd sine beta, must not be equals to 0. There should be some finite value. There have to be among some finite value. That is the reason we have written velocity of sliding is equals to Vc sine alpha minus Vd sine beta. So we have written this, that there have to be some finite value for this. It cannot be 0 for the transmission of power from one gear to another gear. So we have written velocity of sliding is equals to Vc sine alpha minus Vd sine beta. Now we know that we say that Vc means what? We have shown that Vc is equals to Vc sine alpha is basically omega 1 into AC, and sine alpha we have written in the form of sine alpha. If you see the sine alpha, this is the sine alpha. Sine alpha is basically EC by AC, that is EC, this line, this green line, by this black line, AC. So and omega 2 BD into sine beta. Sine beta is also, you could say, sine beta is what? Sine beta is basically FD, this line by BD. By BD, that is FD, this the green color line, by BD, the blue color line. So we write this the velocity of sliding omega 1 into AC into EC by AC minus omega 2 into BD by FD by BD. Now this AC cancels out and it becomes omega 1 into EC minus omega 2 into FD, Now over here EC, now EC is been broken. If you see the line EC has been broken into two parts, that is EP and PC. So we have write this omega EC is written into two parts. Omega 1 is equals to EP plus PC, and FD is written as FP minus PD, and FD is, that is FD, this line from here to here, FD is written as FP minus PD. So we have written that Fe minus PD. Now we just write in that form omega 1 into EP minus omega 1 into PC minus omega 2 into FP plus omega 2 into PC. Now we know that C and D are the same points. Now we can see over here C and D are basically, C is the point of contact of body 1 and D is the point of contact of body 2. So basically C and D are the coincident points. So for that reason we have considered over here PC and PD as the same as the same, and we have taken that omega 1 plus omega 2 into PC plus omega 1 into EP minus omega 2 into FP. Now in my previous lecture we have shown that omega 1 minus EP is equals to omega 2 into FP. That is, from similar triangles we could prove that, we could write that omega 1 minus EP is because I have shown in the first lecture how omega 1 minus omega 2 is basically omega 1 and omega 2 is depend on AP by PB, but over here it could be written in the similar triangle in any form, and these have been proved that omega 1 minus EP and omega 2 into FP is same. So for that reason the omega 1 minus EP and omega 2 into FP is cancels out, and we get this form omega 1 plus omega 2 into PC. Now what is this omega 1 and omega 2? Omega 1 and omega 2 is the sum of the angular velocities of the two gears. So omega 1 is this velocity, omega 1 is this velocity of the gear 1, and omega 2 is the velocity of the gear 2. So omega 1 and omega 2 is the sum of velocity of the two gears into PC. What is this PC? PC is from here, from this point to this point. PC is from this point to this point. Now which is known as the distance between the pitch point and the point of contact, as because we know P is the pitch point and D is the point of contact. So we could say that the velocity of sliding should be equals to sum of the angular velocity of the two gears omega 1 into omega 2, sum of the angular velocities into the distance between the pitch point and the point of contact. Thank you friends. If you like my way of teaching and the way of delivering my lecture, so you can please put a thumb mark to the topics what I have discussed, and you could subscribe to my channel for more videos like this. Thank you. Have a good day.